Where else can you choose from over 300 miles of epic single track against a backdrop of soaring mountains and cascading waterfalls? And where else can you explore 100,000 acres of public lands laced with hundreds of miles of backcountry gravel roads? Your best mountain biking adventure ever begins in Brevard, North Carolina, home to Pisgah National Forest and DuPont State Recreational Forest. 4 primo bike shops will get you sorted, whether you need a rental, service, or some cool swag. Top it off with an array of craft breweries, cafes, and gathering spots that have earned Brevard the title as one of America's coolest small towns. It all adds up to one of the premier mountain biking destinations in the U.S. Find out more at explorebrevard.com. Hey everybody, welcome to the Single Tracks Podcast. My name is Jeff, and today my guest is Will Hart. Will is the product marketing manager at Cane Creek, a Western North Carolina-based maker of suspension and bike components. Thanks for joining us, Will.
Thanks for having me on. I've been looking forward to chatting for a while.
Yeah, for sure.
Pleasure.
Yeah. And we've talked before about suspension stuff for other stories. So yeah, awesome to have you on the podcast. Today, we're going to be talking about coil shocks specifically. So my first question is, besides looking cool, what are some advantages of a coil shock?
I love that. They definitely do look pretty badass, don't they?
Yeah.
Yeah. So great question. Coil shocks, the primary advantages of them is that we say they're more sensitive. A coil spring generally is a little bit more reactive and sensitive to inputs than an air spring is. And so what that translates to is that coil shocks often give a little bit better ground tracking in this kind of more ground hugging feel. Mm-hmm. A lot of riders would say that it feels like they have more grip, it feels like they have a little more control. The bike is, a little more stuck or kind of velcroed to a rough, gnarly, chunky trail. Mm-hmm. That's the main advantage, I would say, is that additional sensitivity.
Okay. Well, I mean, it seems like we all want something that's more sensitive in terms of suspension and ground hugging, especially.
Yes.
So yeah, well, why is that not the default sort of suspension thing then that people use?
Definitely, it has to do with the spring, the overall behavior of the spring over its entire length of its travel. Which, when it comes to shocks, we don't really say shock travel. We refer to it as the stroke. Mm-hmm. A shock has stroke, which then translates to rear wheel travel. But yeah, the reason that I would say it's not the default or the most common shock that you see spec'd out there is that coil springs are generally more linear, which means the amount of force required to compress them increases at a constant rate. And so in simpler terms, it just means that they lack sort of the end stroke support or the bottom out support, let's say, that air shock has. So coil shocks, like I said, they're very stuck to the ground. They're very sensitive, very planted. But the downside of that is that they feel stuck to the ground. They feel planted. And a lot of people like and prefer a mountain bike that feels sort of reactive and sort of springy. Dare I use the very cliche term, poppy? Those sensations are generally better achieved with an air spring. Mm-hmm. And so historically, if you want grip and you want sensitive suspension, a coil's great, but the trade-off is that the bike literally is more stuck to the earth and harder to kind of pop and skip and jump down the trail. Just takes more energy to do so, generally speaking, on a coil shock. So yeah, I mean, nothing comes free. Every single setup with anything in life is a compromise of some sort. And so the sensitivity, the grip is fantastic, but it does represent some sort of a compromise. Yeah.
Yeah. Yeah. Well, when you're saying that with a coil shock, the bike really wants to hug the ground, that makes me think of racing and downhill racing specifically, right? Where in general, you're faster if you stay on the ground. You don't want to be poppy. So are there certain styles of riding that are better suited to a coil shock than others?
I would say sort of gravity oriented riding. Mm-hmm. Downhill racing is a good example, but that could also be not necessarily downhill on a downhill bike with a big dual crown fork. They could just be a rider who just prioritizes going fast down the hill. We say coil shocks are kind of for that rider for whom getting down is the fast is the top priority. That's generally who they're best suited to. Coil shocks are heavier. They're noticeably heavier than air shocks. And so a rider who prioritizes getting up hills, is generally staying away from a heavier component like a coil shock. So I'd say this kind of gravity first. Gravity is my first priority. That type of rider. Generally likes it.
So like enduro too, right? They were the same. It's the same idea where you're being timed on the descents, so you want to be as fast as you can in that. Would it be weird? Like, would there ever be a use case where, like, I don't know, on a cross country bike, like, would it ever make sense to have a coil shock? Or maybe not cross country where weight is something you're thinking about, but like, I don't know, a down country bike where you're like, I have this short travel bike, it's just for fun. Like, would a coil shock make sense there?
Definitely, if you get the setup right. If you kind of can match, a proper or sort of proper, let's say, progressive rate spring that kind of matches up with the suspension characteristic of the frame, it could totally be a lot of fun. We're seeing more and more riders these days kind of choosing these really capable short travel bikes. Things like the Transition Spur is a great example. It's a very short travel, but very kind of modern geometry bike that rides like a little baby trail bike. And we'll definitely see people want to mount coil shocks to those bikes. That bike only has 120 millimeters of rear travel, but with a coil shock and knobby tires and good brakes, you could have this, you could build a bike up that's under 30 pounds and kind of rides like a little baby enduro bike, but just has a snappier, more responsive sensation. So there's definitely a use case for coil shocks on short travel bikes. It's just all about kind of what you prioritize. There's no wrong answers.
Yeah. So I know a question that a lot of our listeners are going to have, after hearing some of the advantages of coil shocks is, can I put this on my bike? And I know when new bikes come out too, that's usually one of the frequently asked questions that they post on their websites is this bike coil compatible? So what makes some full suspension bikes coil compatible and others not compatible?
Yes. So there are two answers to that question, and they're sort of in a hierarchy of most important and slightly less important, but still relevant.
Okay.
So the first one is what I would describe as sort of the overall leverage characteristic of the frame and the linkage. So what is a leverage characteristic? It sounds kind of like an overwhelming term. So if we think about how a full suspension mountain bike is set up, you have a rear wheel and you have a swing arm, a rear triangle of some shape, and you often have some kind of linkage, which I'm using that term to just describe, the various swiveling or hinging components that kind of attach the rear triangle to the shock.
Right.
So based on what the bike manufacturer wants to achieve, how they want the bike to feel, how much travel the bike has, what kind of rider they're trying to sort of position the bike for. They can design, the manufacturers can design different amounts of essentially leverage that the rear wheel and the linkage has on the shock.
Okay.
So as the rear wheel moves through its travel, it compresses the shock. But if you pay attention, you look closely at any full suspension bike, you'll quickly realize that the shock doesn't compress or move as much as the rear wheel moves. The rear wheel moves a lot more. So, and the shock might only compress 40 millimeters or 50 millimeters. So that difference between how much the rear wheel moves and how much the shock physically compresses is described as kind of the leverage ratio. So the rear wheel, a common leverage ratio might be 2.5 to 1, meaning that for every 2.5 millimeters the wheel moves, out of the way of a rock, it's only pushing the shock 1 millimeter of distance.
Okay. Yeah. And when you're talking about the rear wheel movement, you're talking just in the vertical dimension? So 2.5 up and down?
Yeah.
Okay.
Yeah, more or less. It's not dead vertical on most bikes these days, but we can just in our head imagine the rear axle goes up 2.5 millimeters to avoid a bump. And the shock only compresses maybe 1 millimeter. That would be called a 2.5 to 1 leverage ratio. So in order to be coil compatible, because coil springs are typically pretty linear things, you need generally a bike frame that has a linkage that's got a changing leverage characteristic where the leverage reduces throughout the travel. So if a common bike is, we could talk about it in this example, let's say like a specialized stump jumper Evo. Mm-hmm. The stump jumper Evo starts out with very high leverage. The rear triangle has a lot of leverage over the shock early in the travel, and it can move that shock really easily. Uh-huh. As it compresses and as that frame goes through its articulation, the leverage that the rear triangle and the linkage has on the shock decreases. Okay. But it doesn't decrease very much. And when you don't have a very big change, when you don't have a very big decrease in the leverage, mm-hmm. we say that frame has a very linear kinematic. It has a leverage curve that doesn't change a whole lot. Okay. And on bikes like that, they really need air shocks to provide the support really late in the travel. So that's step one. Is the bike coil compatible? Well, the bike needs to have a big change in starting to ending leverage. Okay.
And so like an extreme example would be, I mean, what about like a single pivot, right? Like that's
single pivot bikes. Yeah. They're like exceedingly linear. Yeah. Right. Because they don't have any linkage. And that's usually, to back up even one more step, that's why we see multiple linkages and multiple pivots on a lot of modern bikes, is they're really getting in there and tuning this leverage curve and making it have a great change or a big delta kind of throughout the frame's articulation. Mm-hmm. When you don't have that, like a single pivot bike, that's usually a very, very linear characteristic. So the leverage does not change. The first 2.5 millimeters of rear wheel travel, the shock moves 1 millimeter, and the last 2.5 millimeters, as the bike is bottoming out, still only moving the shock 1 millimeter. Mm-hmm. So that bike would generally not be good for coil shocks. So that's the first thing, linear bikes that don't have a big change in leverage start to finish generally are not great with coil shocks. Mm-hmm. The second criteria is the mounting configuration. This is kind of more of a structural concern. So a lot of modern bikes, again, I don't mean to be picking on the Stump Jumper Evo. I'm just using it because it's a super common bike that a lot of people can kind of picture in their mind.
Yeah. And one that comes with a coil shock, I'm pretty sure. Aren't there builds that come with a coil shock?
The Enduro, Specialized Enduro does, but the Stump Jumper Evo does not.
The Evo does. Well, maybe I've just seen people with coil shocks on those.
I think that's what you use. It is a common like aftermarket change, but that is a bike. I'm using it as an example because it's one that is sort of on paper not ideal for coil shocks because it's a pretty linear kinematic where that leverage doesn't change a whole lot throughout the articulation. And secondly, it has what I'll call sort of a problematic mounting configuration, that being the clevis mount. So picture a bike like a Stump Jumper Evo or a bike like Canyon Spectral or a bike like a YT Capra. Those all have this yoke that attaches to the rear shock eyelet that kind of bypasses the seat tube and connects the seat stays directly to the shock. Mm-hmm. That yoke is called a clevis. Okay. Just another term for it. Those designs, they are really, really handy when you're trying to manipulate leverage curves as a bike designer, or you're trying to fit a shock in a certain orientation to allow for water bottles to go inside the frame or frame storage to go inside the frame.
Or to help with your dropper posts too, I'm guessing, right? Like you have a straighter seat tube.
Exactly. There's all these kind of other variables that you want to every decision that is ever made is a compromise of some sort. So the clevis mount configuration, like all the Stump Jumpers use, is great for all these other kind of auxiliary variables. I'm trying to give the rider a water bottle and frame storage and long dropper post insertion. But the clevis mount in particular is really stressful on shocks because it is like a big long pry bar that you're bolting to the end of your shock. And the length of that clevis, the length of that shock yoke kind of amplifies any sort of lateral stresses that are imparted on the shock. So with air shocks, it's not an issue whatsoever. And that's why you see Stumpy Evos and YT Capras and Canyon Spectrals. That's why you see them all spec'd with air shocks, because an air shock, if you can picture in your mind's eye, has a big air can, this big aluminum cylinder, and then it has this equally kind of big and beefy damper tube that the air can slides on. And those two big kind of oversized aluminum structures act as sort of a brace.
Okay.
And they create this kind of more robust structure that can take that kind of additional lateral load and that additional lateral stress that the clevis imparts on the shock. But picture a coil shock. A coil shock has just the steel coil spring wrapped around the outside and then skinny little damper shaft that comes out of the damper. And it's like not much thicker than your pinky finger in most cases. And so if you'd go off a jump on a stump jumper Evo and land a little bit cockeyed, a little bit sideways, or you have a full bottom out compression, some sort of stressful event, all of that kind of buckling or bending force is going right into that little damper shaft and the seals and bushings that surround it. And so if you try to put typical coil shocks on bikes with clevis mount, typically speaking, again, there's a lot of variables that go into this, like rider weight and so on and so forth. But just in the simplest form, clevis mount is stressful for coil shocks in a way that it just isn't for air shocks. So will it work? Sure. A lot of people do put coil shocks on Stumpy Evos, and a lot of people have a fine experience with it. But is that shock more likely to wear out faster and need rebuilding and service? Yes.
Interesting.
So that's kind of the long answer for what makes some bikes coil compatible. It's the overall leverage characteristic. The frame and the frame kinematic needs to be pretty progressive in order to accept a coil and not just bottom out all the time. That would be if you put a coil shock on a linear bike like a Stumpy Evo, you just bottom it out constantly. And secondly, it's that mounting configuration being sort of, is it stressful on the shock? Clevis mount being the least ideal.
Gotcha. Yeah. So, I mean, based on that, I'm guessing that when a bike brand is telling you if a bike is coil compatible or not, they're probably focusing on the second part of that, right? Because they don't want warranty claims and they don't want any structural issues that could be caused, and not necessarily, I mean, if you want it to ride like junk, like that's up to you, but they just don't want you to break your bike. Interesting.
Yes, they don't want you to break your bike. A lot of times, if you kind of knowingly go against the manufacturer's recommendation, it would be grounds for them to deny, a warranty claim should something negative happen to the frame while you're using this aftermarket shock that's not recommended. So that's always something to consider. There are a lot of options out there these days that are coil compatible and where the manufacturer stands behind that. So if you're interested in coil shocks, look to those bikes, or we'll get to it later in this conversation, I'm sure, look to something like a Cane Creek Tigon, which is a new type of air charged coil shock that kind of remedies everything I just said. But we'll get more on that later. But yeah, it's specialized in Trek and Canyon. They also don't want they don't want the rider to have a bad experience. So I do think legitimately and I totally agree with them. Most riders are going to prefer the way your average rider, let's say, is probably going to prefer the way an air shock feels on those bikes. Right. And they know what they're doing. Those brands are, they've got great engineers making great products. A lot of us ride stump jumper Evos and things of that nature. So it's a fantastic bike overall, but it's all about, if you're going to start playing with aftermarket suspension, it's all about just being aware of the pros, being aware of the cons, being aware that you might be getting yourself in some water where the manufacturer may not be inclined to honor a warranty here or there. It's different with every manufacturer, just things to be aware of.
Yeah, makes sense. And I mean, too, obviously, if you're buying a bike and the brand offers different builds with coil shocks, then that's a pretty good indication that that they agree that it's going to ride well, and B, it'll be safe. Yeah.
Yes. Cool. That's an awesome thing to do. I will do that if I'm discussing shock options with a customer of ours. I'll just hop on the manufacturer's site, and if I'm just scrolling before I look into anything about leverage curves, before I look about how is the shock mounted to the frame, I'll just scroll, through the bike listings. And if there's a OEM build, a stock build package, and I see a coil shock as an option, immediately, yes, okay, cool. This is safe. You can run air or coil on this bike. Yeah, totally.
Yeah. Cool. So now I want to get into sort of how these coil shocks work. And my first question is, how does compression damping work on a coil shock? Is there any air involved at all, or it's just the metal of the coil that's bending?
Yeah, so every proper suspension component has two main structures within it.
Okay.
Think of them as like the organs in the body. Okay. The body is the shock, and shock has two main organs, a spring and a damper.
Okay.
The spring can either be, a sealed air chamber that gives a spring force that way, or it could be a physical metal, a wound metal wire in the case of a coil shock. So the spring, we say that's the thing that supports the rider's weight and maintains sort of the ride height of the system. The damper is a separate structure entirely from the spring, and a damper is what controls the motion and the sort of speed at which the shock can move.
Okay.
Without a damper, you just have a pogo stick,
right?
A spring,
or
a trampoline. Picture a trampoline and bouncing on a trampoline. There's nothing in a trampoline that controls the motion or adjusts the speed or the velocity that the trampoline can launch you. So you just kind of endlessly bounce and oscillate at this sort of uncontrolled. Bouncy is just think bouncy. Bouncy is, if you really think about it, it's not a good sensation. You don't want a car to feel like a bouncy ball as it's going down the road. Right. Same with a bike down a trail. So the damper is a hydraulic system that relies on oil being forced through little holes, little valves.
Okay.
So picture like a French press. A French press is a cylinder to make coffee, and there is a plunger.
Right.
And there's that metal mesh screen that you strain the coffee grounds with. Picture the sensation when you press down your French press. There's resistance as you're forcing the fluid, that be the coffee, through the mesh. There's a resistance to it, and it's smooth and it's kind of steady. And likewise, if you try to pull up on the plunger on your French press, there's also resistance pulling up.
Right.
It's smooth and steady. If you were to increase or decrease the fineness of the mesh, you would make that would be harder or easier to push. Like if your French press had no mesh on the plunger, it would fly right through the fluid when you press on it. If it had a mesh that was way tighter, then you'd have to use a lot more energy to force it through the coffee. That is exactly how a damper works. So picture in your shock, there's a tiny little French press. Instead of coffee, it's oil. And instead of the mesh plunger, it's a similar piston head with little holes in it. Essentially.
Like a disc. I'm guessing it's like a disc with holes, a certain number and size of holes.
Correct.
Yeah.
And then, there are different other small parts that cover those holes that kind of you can increase or decrease their stiffness and how hard it is for the oil to flow through. So the damper is what controls the motion and the speed that the shock moves. So back to your question, how does compression damping work on a coil shock? It works exactly the same as it works on an air shock.
Okay.
In fact, a lot of suspension companies, ourselves, Fox, RockShox, they make, kind of two shocks in one family, one with an air spring, one with a coil spring. And the damper structure, so the little tiny French press full of oil that's in the center of the shock, that's often the same.
Okay.
Same exact thing. It's just one is wrapped in a sealed air chamber, and that's providing your spring force, and one is wrapped in a big old piece of steel wire, and that's providing your spring force. So compression damping, there's no air involved generally in damping. Air damped shocks do exist and have existed in the past, but they're sort of few and far between. Cane Creek's first ever mountain bike shock was air damped.
Oh, wow.
Believe it or not. It did not have oil. It didn't have any oil in it. Pretty cool. It's super lightweight. This is back in the mid 90s, 1995 to be exact. But air damp shocks are not really a thing in the mainstream anymore.
Yeah.
They are all damped with oil. Oil provides that resistance to control the motion. So the shock is not just pogoing and endlessly oscillating and bouncing. I'm bouncing in my chair as I'm saying this. I can't talk about like yes, down the trail, which is not a good sensation.
Yeah.
Yeah. Does that kind of answer the question?
Yeah, absolutely. That's super helpful understanding. Like, I mean, it's basically, like you said, it's two systems. There's like the air and then there's the oil-based damping system. Yeah.
Yes.
So like how much oil are we talking about? Like what's the volume that this essentially disc is like kind of moving between?
Yeah. I wish I knew the actual volume of oil in like milliliters that I could tell you off the top of my head. I don't.
Is it like how much you would put in like a little medicine cup, like you're taking your allergy medicine?
Picture like a little pill bottle. Is that kind of what you're describing?
Yeah. Or no, like the little plastic thing you like take liquid medicine with,
Oh, it's more than that. It's more. I think that's 30 milliliters. It's probably a little more than that in a lot of shocks. Don't quote me on that. I do a lot of this kind of like technical interpretation. That's kind of what I do for Cane Creek. I'm definitely not an engineer. So definitely want to clarify that with the world.
Well, yeah, that helps though to like understand, especially when you're looking at a shock. I mean, I'll be honest, like that to me was confusing, or, you see a coil shock and you're like, okay, it's about the same size as an air shock. And there's like this big bulky part at the end of the spring.
Yep.
And so, I'm wondering like what's in there. Is it air? Is it oil? So it's oil, and it's, that helps kind of give us the idea of the scale of that portion of the shock.
Exactly. Yeah. It's that center kind of portion. The majority of the damper and the majority of what's going on is kind of in this center tube that the coil spring is wrapped around. Mm-hmm. And that tube, I'm holding one in my hand right now. It's about the size of a pill bottle, an average prescription pill bottle.
Okay.
And that's full of oil and that piston that we talked about with the little holes in it. And so that little French press of oil is going back and forth, and that piston is being shoved and then pulled back and forth through the oil.
Mm-hmm. Yeah.
And that is kind of controlling the motion of the shock. And
gotcha.
Yeah, and then the external part, you'll often see on a lot of coil shocks, since we said coil shocks are kind of often like more targeted to sort of more downhill or gravity-oriented riders. Mm-hmm. There's often, in an effort to fit a bit more oil and give a bit more damping force and more control to the shock's movement, there's often an external reservoir, which a lot of people refer to colloquially as a piggyback.
Right.
And that's the little like tube or cylinder or reservoir that kind of sticks off the head of the shock. It's the technical term is the valve body. And that is just space for additional oil. Mm-hmm. And then there's usually some sort of either a small piston or a bladder in there where you can pressurize the oil. Okay. Because it does need to be under pressure so that it doesn't sort of essentially turn into like a foam latte. Mm-hmm. So there is a pressurized air aspect that keeps the oil in the damper under pressure, but it is not that bit of gas. It's nitrogen. It doesn't really have much to do with the suspension performance. It's more to do with keeping the oil stable and not cavitating. It's just that property of the oil in the damper is essentially foaming.
Yeah. Okay. Yeah. And that's, so that air volume too, you're not changing it. It's not something you're going to like pump up or.
You're not going to touch that. And most people aren't even aware of the fact that there is a nitrogen charge, a gas charge on the oil. It's something that's set at the factory and generally not messed with unless you have a full rebuild of your shock.
Yeah. Gotcha. Cool. So that leads us into my next question. Tell us about the Cane Creek Tigon. So this is a coil shock that's combined with an air spring, right? It's a coil and an air together. So what's the idea?
Yes. So this is super, super exciting topic. We launched the Tigon this past fall. So it's not even been out a year yet. And it's really kind of the first thing of its kind in the modern era here. It is an air-charged coil shock. So it's a coil shock primarily. Mm-hmm. The rider's weight and the primary kind of like ride characteristics are still that of the rider's weight is supported by the coil spring, and the ride characteristics are more in line with a coil shock. But there is a small air shock built inside of it. We essentially took an air shock, shrunk down the air can so that it's really slender and such that you could then kind of fit a coil spring over top of that small air can. Okay. And the whole purpose of the Tigon is that you get both the sensitivity and the grip and the ground tracking of a coil shock, and you get this tunable support of the air spring. We haven't talked about it much so far, but the main benefit of air shocks is that they're more tunable. They're adjustable. Right. You simply put a shock pump on and you can make the air pressure, therefore the spring rate, be whatever you want it to be. If you want more support, you just load that thing up with more air, and it's harder to use all the travel of the shock. So, that's the benefit of air. Tigon allows us to have that. You get both sensitivity with support. It eliminates a lot of the downsides of the coil shock. It eliminates that kind of ground hugging, stuck to the ground sensation, and gives you more this kind of ability to add some pop, some liveliness into your coil shock. And lastly, because of that little air can and sort of the layout structurally of the shock, it allows us to make a coil shock that is now compatible with the number of bikes who structurally would not really suit a coil. Like, again, I'm going all the way back to bikes like with the clevis mount, like those Stumpy Evos. You now have a shock that is so much stronger and more resilient to sort of lateral buckling forces because it's behaviorally, it acts like a coil shock. Sort of structurally, it really is a little air shock. So best of both worlds kind of thing. Yeah, the Tigon is a super exciting thing. We've all been riding the absolute crap out of it, and yeah, it kind of expands the market, the usable market for coil shocks in a way that we haven't really seen so far.
Yeah. What about on the ride characteristics side of it? Like, is it would it be a slightly better choice on a single pivot bike?
Yes, it definitely would. Okay. It'd be a much better choice on any bike that's got kind of a linear kinematic. Bikes that don't have a big change in leverage throughout their travel, like single pivot bikes. Yes, the Tigon's fantastic. It really is just kind of what your very first question. You were like, well, why doesn't everybody want sensitivity and traction? Like, that sounds like good suspension to me. And the answer is yes. And Tigon kind of allows a lot of people to have that now on bikes that aren't necessarily designed for coil shocks. So it's kind of a problem solver shock in a way. It's sort of you could think of it in that way. You can have your cake and eat it too a little bit.
Yeah. Well, why hasn't anybody done this before, or has somebody done this before? And
it has existed in the past. Yeah. It has existed. There was in the 1990s, there was a shock called the Helix Stratos. I believe that's what it was called. And it was this sort of like combination coil and air shock concept. It was pretty rudimentary. It didn't have a ton of adjustments. It was like a lot of mountain bike components from the 90s. It, was just, I think, rudimentary is, I guess, a good word without being like condescending to it, which would not be fair, Yeah. And there are in the motorsport world, there are some examples of sort of combination like coil and air suspension systems. Yeah. Why has it not been done in the bicycle world? Well, I don't have a great answer other than the fact that it's more complex. Yeah. It's a little more expensive to produce. It's a little bit harder to understand, I suppose. The setup is slightly more intricate. So yeah, I think kind of just for simplicity's sake and just for the sake of the status quo, which is a very powerful thing in kind of the consumer world. It's even a powerful thing in the racing world. Racers.
Oh yeah, for sure.
Racers do not like changing setups and often breaking status quo. So in a lot of design, for better or for worse, at Cane Creek, we think sometimes for worse is driven by what are the demands of professional racing and what racers do. Who racers are and what they do is just often not relevant to the way that you and I ride our bikes. Yeah. And so that type of design thinking and design approach has limitations. So yeah, but we have a patent pending on the technology built in the Tigon. So the Tigon uses what we're calling ramp tube technology, and the ramp tube is that small secondary air spring that this coil shock uses. We have a patent pending on that, and that's something we're super proud of and excited to have. And who knows what the future holds? There could be some scenario, some reality where in the future other suspension companies are licensing this technology from us in the way that everybody and their sister licensed threadless headset technology from Cane Creek for the first 20 years of the threadless headset being a thing. So that would be awesome to see that happen with ramp tube and sort of this air charged coil concept. But we don't need to get ahead of ourselves. Like I said, it hasn't even been out a year. We're stoked on it. A lot of our riders and early adopters are really pumped on it, but time is the ultimate determinant of what everyone will go for.
For sure. Well, you mentioned that, obviously coil springs are very linear.
Yes.
But you also see coil springs that claim to be progressive or like more progressive. How is that possible? Like, I feel like I've seen ones where they try to like have different materials, or the winding on the coil is a little bit different. Like, is that a real thing? Can you make a coil spring more progressive?
Yeah, you can. So maybe before I answer the question, I'll just kind of give a quick clarification for those listeners. Linear and progressive are terms that we throw around a lot, and I just kind of we can establish a little baseline here. Yeah. A linear spring is one where the force required to compress it each inch increases at the same rate. So picture a spring that can compress 3 inches.
Yeah.
And picture this spring is a 400-pound rate spring. So what that means is that it's each inch of the 3 inches takes 400 pounds to compress. So to compress that 3-inch spring, the first inch takes 400 pounds of force. The second inch takes
800. Yeah.
800 pounds. Yes, because it's 400 plus 400.
Yeah.
The last inch, 1,200 pounds.
Yeah. Which doesn't seem linear, right? I mean, like if you're just thinking about, it requires more force as you go.
It does require more force, yes. Yeah. But the rate at which the force increases is constant.
Yeah. It's like acceleration. It's like...
Yes. It's not like exponential. The opposite of... Yes, it's the shape of the change, the shape of that curve. So a straight line increase, just a line on a graph, on an XY plot, a line that goes up in a straight line at 45 degrees is a linear increase.
Right.
A progressive spring would make an exponential curve. So each inch that you compress a progressive spring, it gets exponentially harder.
Right.
So instead of going 400 pounds, 800 pounds, 1,200 pounds, it would go like 400 pounds, 900 pounds, 1,500 pounds. It would jump in increments that are uneven and getting bigger and bigger. So the progressive spring is harder. It takes the same amount of energy to move it through the first inch of the stroke, but it takes way more to fully compress it. And that's kind of the concept there. So, okay, we feel like we've established that well. So to answer the question here, is it possible? Yes, they do exist. Most coil springs, if you just look at any old coil shock on a bike, or you look at any old coil shock on the internet for sale, or in a bike shop, typically those are equipped with linear rate springs.
Okay, yeah.
That's the standard. That's the baseline for coil suspension, is linear rate springs. If you're trying to get a shock that has a spring that's harder to bottom out, that has a lot more support in kind of the latter half of the stroke, then you would want to get a progressive rate spring. And yes, I mean, like mechanically, how does that happen? We sell them. Cane Creek makes both linear and progressive rate springs. It's largely to do with the frequency of that wrap. Okay. So if you look at kind of like a linear rate coil spring, the distance between each wind of the coil is very consistent. So all of those winds kind of compress at the same rate. If you look at one of our Vault progressive springs, the wind, the frequency of the wind increases as it gets towards the end of the spring, which makes it which changes that characteristic. So the way it works is that on our progressive rate springs, you'll see like instead of one number for the spring rate, so instead of just saying 400, it would be 400 to 500.
Okay.
And what that means is that through the first half of the stroke of the spring, it's about 400 pounds per inch to compress it. But once you get kind of past halfway and you're getting on towards full compression of the spring, it starts behaving like a 500 pound per inch spring.
Okay.
So it changes its kind of behavior from 400 up to 500. That's what that label means. So if you see a spring that's got two spring rates printed on it with a hyphen in between the two, that means it's a progressive rate, and the rate of change is increasing more sharply.
Gotcha. Cool.
To give more support, to give more in-stroke support. That's what progression is all about. Just in-stroke support.
Yeah. Awesome.
Some people would say bottom out resistance, but bottom out is kind of over. It's bottom out resistance is a small piece of the puzzle. In-stroke support is something that you use all the time.
Right. But bottom out
happens in a moment, in an instant. But a lot of people kind of fixate on that instant of the bottom out event. In-stroke support, as this whole concept, like has so much more to do with how your whole bike performs and rides.
Gotcha.
How supported it feels when you're kind of past like 50% of the travel. And that is really what, wanting a more progressive setup is kind of what it's all about.
Okay. Yeah. Well, let's talk about bottom out on a coil shock. How does that work? How is that different from, or is it different from an air shock?
Yeah, it's essentially the same thing. There's a little, when a shock bottoms out, it's reaching full compression. It's reaching the mechanical end of its usable stroke. And there is a little rubber bumper, a little polymer or rubber bumper in all shocks that kind of helps soften.
Yeah, so it's not metal on metal.
Not metal on metal. Coil shocks, because they are more linear and they tend to use their travel more easily. Coil shocks generally have bigger bottom out bumpers, and you can see it on a coil shock, so it's really easy to visualize because you can look through where the bottom of the spring kind of sits on the spring perch. Yeah. And there's a big old, just like wedge of sort of a soft rubbery material that softens that last 10 millimeters of the shock stroke. And in air shock, you still have that. It's just inside the air can. You can't see it. And it's generally smaller because air shocks have that naturally ramping in-stroke support. So they don't really need as much of this mechanical bottom out resistance.
Yeah. Okay. Yeah.
Some coil shocks have like additional systems that help mitigate bottoming out. So a popular thing that you'll see these days on a lot of competitor shocks to ours are hydraulic bottom out controls, which use additional architecture within the damper. And again, back to that kind of the oil and piston we were talking about earlier, there's additional valving that uses oil pressure to slow the shock down right at the end of its travel, so you don't have as much of a hard bottom out sensation. Yeah. That's really common on big coil shocks these days. The other thing, again, back to our new shock, the Tigon. Tigon uses the ramp tube and that little baby air spring that's part of the shock that acts as sort of a bottom out mitigation device.
Okay.
We like to not think of the ramp tube as just a bottom out control because it does so much more for the shock than just simply stop it from bottoming out. But yes, ramp tube does. One of its many benefits is it helps support the shock right at the end of the travel, and you don't have as hard of a bottom out event as you typically associate with very linear coil shocks.
Yeah. Yeah. Maybe you said this earlier when you were talking about Tigon, but is the air spring portion of it, are you feeling it more toward the end of the stroke? That's kind of what it sounds like you're saying. Or is it affecting the stroke throughout, like from the beginning to the end?
It depends how much air pressure you have in it. That's a good question. You can run Tigon with no air in it, and then it's just a simple linear standard coil shock. But if you want that support, you can put anywhere up to 30 psi in the small air chamber. And at full pressure, so at 30 psi in the Tigon, it really the air starts supporting you right around sag. So right around 30% of shock stroke. And then, kind of from yeah, I mean, it can be zero or it can be quite additionally supportive.
Okay, gotcha. Well, yeah, speaking of sag, how do you set sag on a coil shock?
Yeah, sag is super important. I'd say if there's one suspension setup advice I have above anything else, it's make sure your sag is set correctly. So many riders focus a lot on other things, and they kind of have neglected setting sag. So on an air shock, it's a little more obvious because you can simply adjust it with air pressure. On a coil shock, the first step to finding the right sag, which is again the amount that the suspension compresses just under your kind of resting body weight, you have to calculate the spring rate. So you have to do a bit of math. You want to do the average way to start to figure out your spring rate, which spring to choose for your coil shock, is to take the rear travel, the amount of rear travel. So let's say 150 millimeters, divide that by the shock stroke. You can find the stroke of your shock by looking on the spec list often of your bike. So a common shock size on a 150 travel bike these days might be a 210 by 55. So what that means is that shock is 210 millimeters long with a 55 millimeter stroke. So the shock actually only compresses 55 millimeters. So to calculate spring rate, you'd want to do the rear travel. So 150 divided by the stroke, 55. Multiply that value by your rider weight.
Okay.
And then that spits out a number. And that number is going to be 450 or 560 or something like that. That number is your analytical spring rate. And that's where you start.
Okay.
So that's you go to, you want to try a Tigon shock on your Stump Jumper Evo. You head to canecreek.com. You've done the math, and your analytical spring rate is 467.
Okay.
You would want to select a 450 round down. You always want to round down to the closest spring rate available, a 450 pound spring. That's kind of where you start. Then you would put that on the shock, you install it, and you then adjust the preload on the spring until the shock is, the suspension is sagging the amount that you want. So if you want 30%, if you want, a really nice high traction, high ground hugging sensation, maybe shoot for 30% sag on your trail bike. You would then adjust the tension on the spring with the threaded spring clip or preload collar. There are different terms for these things that we all love how the bike industry, seems to not ever have a codified terminology. But yeah, you have the preload ring or the spring clip, some people call it. And you adjust the tension there so that there's just the right amount of starting tension on that coil to be at the ride height or the sag that you want. So that's kind of how you do it. It's calculating the spring rate on paper with your calculator and then buying the right spring and then fine tuning it when it's on the bike with the preload ring, sort of twisting that collar 1 to 2, maybe 3 times maximum to fine tune how much the shock sags.
Yeah. Well, so I've noticed though, it seems like a lot of coil shocks, they don't have like the little O-ring. Is that right?
Yes. Yeah.
Yeah. So how can you tell how much it's sagging or how much it's actually like percentage wise?
Yeah. That's a good question. What I often do is kind of measure the distance eye to eye of the shock. Hopefully you have a bike where you can see both shock eyelets and you could get your ruler out and you could kind of figure, okay, my shock is 210 millimeters long when it's fully extended. What is 210 minus, well, you figure out the stroke. This is where it gets tricky. You got to really double check yourself. You want the shock to sag, let's say 30% of the 55 millimeter stroke. So you figure out, all right, what's 30% of 55?
Right.
Subtract that from 210.
Yeah.
And that would be kind of what you'd want to measure as the new compressed length at sag when you're sitting on the bike. So you have to get a little creative.
Sounds like you need a friend because you're sitting on the bike and they got to measure it for you.
To hold up a ruler to measure, how much
you need to be good
compressed.
at math. All of this from start to finish, you need to be able to calculate some ratios.
So all of that said, you can kind of start to see why air shocks, for a lot of riders, air shocks are simpler.
Mm-hmm. Yeah.
You have the little O-ring indicator. You can do it by yourself. You can sit on the bike. You can get off. You can measure how much your O-ring has moved on your damper tube. Yeah, air shocks are no doubt simpler.
Mm-hmm.
Tigon, because it has a small air component to it, a small air can, we are able to actually inscribe sag indications. We have little lasered indications on the damper tube on a Tigon. So it is a coil shock that you still need a friend. You still need a friend to eyeball those because there's no O-ring that slides, but there are lasered indications of how much the shock is compressed. So Tigon is like one step easier than typical coil shocks to set sag in that respect.
Yeah. Well, so you mentioned that you have to choose the right coil spring based on your weight and the leverage ratio of your bike. Mm-hmm. So for that reason, is it difficult for lighter weight riders to find an appropriate spring for certain bikes?
Sometimes, yeah. It really, I would say it can be, and this is sort of an unfortunate reality, but it can be difficult for really light or really heavy riders to find coil springs. It just depends on what the manufacturer produces. The lightest coil spring, the lightest spring rate that Cane Creek produces is 350 pounds. Mm-hmm. So on your average modern trail bike, that means that if you're lighter than a lighter rider than 130 pounds, you may kind of struggle on most bikes to get enough sag to have the suspension compress, an amount that would give you substantial grip on the trail. Mm-hmm. Likewise, if you're a quite heavy rider compared to the average, there's scenarios where if you need a 700 or 750 pound spring, smaller companies like ours, like Cane Creek, unfortunately, we just don't have the ability to produce that, in our lineup. And so, there are some companies that make a wider range of options, but generally, if you're generally between, let's say, like 130 pound rider weight up to maybe, 250 pound rider weight, somewhere in kind of that realm, it's generally pretty easy to find a coil spring that will work for you.
Yeah. Is it possible to mix and match? Like, could I put a RockShox spring on a Cane Creek shock, or do they use like different dimensions? Is that what I'm going to run into?
Yes and yes to both your questions. Sometimes they can be cross-compatible. You just have to confirm those dimensions. So the crucial dimension is the inner diameter of the spring. So for Cane Creek, our shocks are definitely compatible with a number of other brands' springs. Mm-hmm. Öhlins springs fit our shocks. RockShox springs fit our damper bodies. But you cannot put a Cane Creek spring on a RockShox shock, for instance, because the RockShox spring, the inner diameter is bigger than ours. So you just have to be aware. But yes, if you can't find, and that is something that I have done in the past, there have been instances where somebody is trying to outfit a really lightweight rider, like a 120 pound rider, and they need a 300 pound rate spring. I have been able to direct them to our friends over at Öhlins. We're good friends with the folks down the road in Hendersonville, North Carolina at Öhlins. And they make a slightly wider range of spring rates that fit our damper bodies. So we have a nice little, there's some workarounds there for sure.
Yeah, awesome. Well, one question I have is, because coil spring is a piece of metal, is it going to feel different over time as it fatigues, like after it goes through just like thousands of these cycles of compressing and uncompressing?
Yeah, that's a good question. That's this is a cool one. This one I went before our chat here. I'm glad you gave me some heads up on this question, because this is when I had to go ask the engineers. And our kind of lead suspension engineer, Brandon Blakely, was telling me that it depends on the material used and the design, but our springs and most modern mountain bike coil springs have essentially an infinite lifespan.
Whoa.
The way it's magical. It does, right? It sounds impossible. I know my own eyebrows went up slightly, but yeah, we use a high quality steel in our springs, and steel is a wonderful material structurally for a lot of reasons. But if kind of, wound correctly and designed correctly, and if it's used in an appropriate manner for its design, that's the asterisk by statements like this, they can essentially go infinite number of cycles, and there will be no measurable fatigue. It's not going to break eventually like a paperclip. Aluminum is the opposite.
Right.
Aluminum is one of those materials that will fatigue and it will break. Steel is the choice for a spring. But yeah, Cane Creek springs, no measurable decrease in the performance over time, and that's the same as most in the bike industry these days.
Yeah. So I'm guessing, are all coil springs steel, or I feel like
most of
maybe
them, yes.
is like titanium a thing? Like if people are trying to save weight, like do those exist? Yeah.
Yes. Titanium springs exist for sure. They're really expensive.
Yeah.
They save a little bit of weight. When it comes to material properties, I'm not enough of a materials engineer to make a great claim on their durability, but I know just anecdotally, steel is a more dense material, and generally, in terms of wear life, things made of steel are stronger.
Right. Yeah. Right.
A lot
it
of
makes sense.
go into that. Yeah.
We'll just leave that. We won't make any claims about whether titanium wears out quicker. But hey, if you're the kind of person with a titanium budget, probably fine buying a couple of them and just having like a spare.
Yeah, it could be cool. Yeah, it could be cool to save a bit of weight. But yeah, most springs are steel, and if you get a steel spring, there's no worry that in 10 years you need to stress if it's going to suddenly break on you or something.
Yeah. What about other maintenance concerns? Is a coil shock going to be lower maintenance than an air shock over time?
There are fewer sort of delicate moving parts and fewer seals on a coil shock. And so, some people sort of will cite them as being more durable or more reliable. There are no airtight seals that have to hold in, 300 PSI like you have in an air shock. So there's that aspect. There's still seals and oil and small parts inside the damper that need to be serviced and need to be replaced in time. That oil inside your damper gets dirty. And just like the oil in your car, even though it's in a quote unquote sealed system, it gets really dirty quite quickly. And you gotta replace the oil in your car. You gotta service and replace the oil in your damper, even if you have a coil shock. And you should do that on the recommended service interval.
Okay.
For our stuff, it's every 100 hours of riding, or annually, kind of whichever comes first.
So that's the same, that 100 hours is the same for your coil shocks and your air shocks.
Yes. Now, some suspension companies recommend a 50-hour service that is just an air can service to sort of replenish the lubricating oil and the seals that make up the air spring. We do not have a 50-hour service on our air shocks. So the Cane Creek air shocks are a little bit unique in that respect. We just say 100 hours for everything. So if you were talking about Fox, well, I don't want to speak because I haven't read with my own eyes what their service recommendations are recently. But let's say if you're looking at another suspension manufacturer, they may very well say 50 hours for an air shock, and then maybe their coil shock, they say every 100 hours. So you could make that argument with our stuff. We don't really say, our coil shocks can go longer without service, because both of our styles of shocks, we say 100 hours.
Yeah. But at least I guess maybe one thing, this isn't like necessarily maintenance, but in terms of like checking the air pressure on your shock, like, I don't know. I don't do that a lot. Maybe I should like check it every other ride or something, or certainly like if you're going to altitude or something. I know that's a concern with air that maybe you wouldn't have with
temperature affects air shocks quite a bit. Yeah. So none of those altitude changes, none of those temperature changes affect coil shocks and the way they behave. You definitely, there's less to go wrong with a coil shock. There are fewer seals that could fail. If you get a small nick or a small just failure of a seal in an air shock, it could suck itself together, or it could leak air.
Yeah.
There's no like showing up to the bike park and suddenly your coil shock is leaking air and your bicycle vacation's ruined. That can't happen with a coil shock. So there are ways in which a coil shock you could argue it's more reliable, but from a service perspective, I will just say, again and again and again, these are high performance items. Like, you still need to service them on the recommended intervals.
Okay.
Yeah.
Cool. So finally, I want to ask you, this is a lot of great information, and I know a lot of people are interested in coil shocks and maybe they haven't tried them yet. What's your advice for mountain bikers who are coil curious and are thinking about maybe they want to give this a try or they want to run a coil shock on their bike?
Yeah. I would say if you're curious about it, first advice is go for it. Do it. We ride bikes because it's fun, because it's cool to tinker with these very, very cool toys. And so go for it, try it. You don't know. One thing we like to say a lot around here is you don't know what you don't know. So, if you've never played with one, you could be missing out on something that makes your mountain biking experience a lot better for the way you ride. If you try a coil and it's not for you, you will know that you're an air shock rider, and you will be more confident in that knowledge, and you'll just be a more knowledgeable mountain biker. Yeah. You will have understood more about how suspension works. I think coil shocks help people understand a little bit more how suspension works, because you kind of separate and break down those two organs of the body that I kind of referenced earlier in the talk.
Yeah.
So try it, check if your bike is coil compatible, see if it's stated on the manufacturer's site, if it's safe to use with coil, see if you can find information about the leverage ratio of your bike. Is it fairly progressive? We say generally bikes that have somewhere around a 20% or greater change in leverage, start to finish, are generally ones that suit coil shocks well. So if you look up and you do some research online or talking to a dealer and you find that your, mid-travel trail bike, it has, something stated of it's 25% progression in the kinematic. You see that 25, that's some number in that range, like I said, around 20 or greater, then you can know, okay, cool, that has a big enough decrease in leverage that a coil shock will play well. Make sure that, you have a bike with sort of a safe mounting configuration. And if you don't know, or if you're unsure, call Cane Creek, or send us an email. We have, folks whose whole job, full-time job is helping determine, is a bike well suited for a coil shock or not? So we can help with that.
That's a great resource.
That's what we do. So reach out. I'd say if you're looking to spec a coil shock on a short travel bike, so maybe something 130 millimeters of rear wheel travel or less, I'd say you could probably go with the progressive spring across the board. A lot of bikes, 130 travel or less, are just going to have leverage ratios that require progressive springs for the most part. So that's a place to start for those bikes. I think a huge piece of advice is get 2 springs to start out. When you're doing your first calculation for your analytical spring rate, if you do your spring rate calculation and you come up with the number 470, and you're looking at the selections online or at your bike shop, and there's a 450 pound rate spring and there's a 500 pound spring, and you're ooh, I calculated 470. Should I get the 450 or the 500? Should I round up or round down? I don't know. Get both.
Okay.
Get both and experiment with both. See which one you kind of yields a better ride height, a better sag amount that's preferable to you. So that's a piece of advice, is to have several springs to play with.
Free returns on those, I guess. You're gonna return one.
Return one. You're not going to really trade them out for different scenarios. You might, but generally speaking, your spring rate is just determined by your weight, and once it's on there, you don't mess with it.
And they don't fatigue, so it's not a big deal if you end up with a used one.
Yeah, right. The last piece of advice is that you could also seek out coil demo programs similar to the one that we offer. So actually, this is perfect timing, because literally, I think it was last month. I think it was either late January or early February. We ourselves, Cane Creek, cycling components, have introduced what we are calling a Coil Curious demo program. So here in-house, if you want to make the trip down to Fletcher, just south of Asheville, North Carolina here, we have an in-person sort of demo test ride program where we will check out your bike, see what coil shock might be well suited for it, outfit your bike with said shock, go with you to the trail, a one-on-one session where we'll help you tune the shock, adjust it, select the right spring rate, test it out. It costs $100. If you aren't happy with the way your bike feels and you kind of prefer the way that the stock air shock felt, we'll put the air shock back on, send you on your way. You've learned a lot about suspension and got to test ride cool shocks, and it only was $100 experience. That's an option for people. The Coil Curious program, if you come to us and we set you up and you pay the $100 and you decide to keep the coil shock that you demo and tune, we just apply that $100 to the cost of the shock.
Wow.
So the demo and test ride effectively becomes free if you end up buying the shock.
Wow.
So we offer that. Again, that's only something for a rider that wants to make a trip here to Western North Carolina. We would say do it.
Which a lot of people will. I mean, like it's a cool spot that I know a lot of people have on their radars anyway. Like they're planning a trip out to Pisgah. Yeah.
We have some of the best mountain biking, on really in Eastern North America. We have some of the best. I'm not going to claim it is the best.
Some of the hardest too. I would qualify that a bit. We
have some rad stuff. Yeah. We have a lot of world level professional mountain bikers that live and train here, many, many times champion downhill rider Aaron Gwynn, just bought Windrock Bike Park, which is just, across the mountains in Tennessee from where we are, but still in this immediate region.
Yeah.
So there's a huge scene here. The trails are fantastic. If you're thinking about a mountain bike vacation in the next year and you've had any curiosity about coil shocks, come take a trip down to Western North Carolina and Eastern Tennessee and test a coil shock with us at Cane Creek. But otherwise do it, try it, find a bike shop that'll let you try a shock on your bike. It's all about learning. It's all about the more you know.
Yeah. Awesome. Well, Will, thanks so much for taking the time to chat with us. I learned a ton and I'm sure our listeners have as well. So thank you.
Fantastic. Yeah. This is awesome stuff to share. This stuff can be pretty dense and it takes multiple passes to, I feel like, really understand it. You have to do it a lot to understand suspension, how it works. I've been working with bikes working with bicycles has been my full-time career for 7 years now. And I like today, 7 years into full-time working with bicycles, today I learned that steel coil springs don't fatigue. It's just,
right.
You always are learning. And so it's bit by bit. Don't get overwhelmed by it. Suspension, you can master the suspension on your bike, if you just break it down and take it one step at a time. But no, thank you so much, Jeff, for having me on. And maybe we'll get to chat in the future about more cool bike parts and innovations and things like that.
Yeah, awesome. Well, we'll have a link to Cane Creek's website in the show notes here, so you can find out more info and maybe set up one of those demos. That's all we've got this week. We'll talk to you again next week.